So I want to answer that right now. We'll wait for this warm up. Let's answer the question anyway. And this has kind of a silly kind of sappy emotional connection to that you bring this up, and I'll mention it to you. So the billion seconds deal, it's for you guys to figure out why it's 31.7 seconds or 31.7 years. And if you think about that, you think about a second and the word a billion. I'm sure that you don't think about, oh, it's a billion. You know, it's a billion seconds. Like that can't be more than like a week, right? Because years ago I read in an educational journal, one way to get kids interested in mathematics is to walk in one day to class. 999,999,999, 1 billion. I did it. I counted to a billion. And then the kids are going to be like, oh, really? I'm like, they're not going to care. They're going to say you're out of your mind. So I said, phrase it in a better way. So that hence the question that you have in front of you is, how old are you if you're a billion seconds old? So, and then there's a Bill Gates question. I'm not sure if they did the Bill Gates question on there as well about how much money he would stop for to pick up. I may have taken that one off. I'm not sure what's on that project. I keep changing the question for that project as I find new ones. Took that one off. So the idea is to kind of instill in you a kind of, holy crap, that's a lot. So to know that a billion seconds is 31, almost 32 years is kind of crazy to think about. But then the question is, okay, how about a million? What's a million years? Or a million seconds? A million years is a long time. What's a million seconds? So let's crank a million. Okay? So if you have a million seconds, and if you haven't done the project yet, this will help you see how to do that. So help you kind of see how to do the billion second question. So if you have a million seconds, using that dimensional analysis tool, the million seconds, I'm going to bring my board and do the TI at the same time, that might help. So if you have a million seconds, the part of the project, and this seems to work for most students, that's why I kind of show you on this project the way I'm showing you by multiplication, by fractions that are all equal. If you have a million seconds, in order to convert that to something useful, you have to multiply it by a fraction that's equal to 1 in value, but changes the unit from seconds to something else. And the way I showed you in the project, some of you are not, like, already seen it, or you've seen this way before, is just by step. If we want to get seconds into something meaningful, let's go with seconds to minutes first. Okay? So let's turn seconds into minutes. Well, 1 minute is therefore 60 seconds. Now the ratio of those two things is equal. 1 minute is 60 seconds. So multiplying a million seconds by 1 minute over 60 seconds, what that's going to have the effect of doing, essentially, is changing the seconds to minutes. You're still going to call it the same length of time, but now it's going to be in a more logical kind of construct. Does that make sense? So the seconds are going to cancel. You're only going to have minutes left. So let's see what that looks like. Let's multiply it by 1 over 60, which is the same as divided by 60, right? Yep. So now we're down to that. And we'll just come over here, maybe. Now, this is a little bit weird how I'm doing this, by doing it one step at a time. In the project, I think I showed you how to just multiply everything in one big long row, cancel. But this kind of explains to you what's going on. So now you've got this number of minutes. Let's go underneath. Yeah, we'll skip this way. So now you've got that many minutes. What's the next logical time unit maybe we should go to? Hours. How about minutes to hours? I think that makes sense, right? How many minutes in an hour? 50 again. Now some of you might say, why don't we just divide by 3,600 and go straight from seconds to hours? Sure, that's fine. But if I bust out 3,600 without really explaining where the 3,600 is, it might be like, I don't get it where 3,600 come from. This way you can kind of see each step as you go. All right, times 60 minutes to 1 hour. So again, this occupies the same realm of units as the previous one did, except now we're going from minutes to hours instead. And the nice thing about that is minutes cancel. Minutes cancel. Fair enough? Fair enough? Good. Let's see what that is. Let's divide that by 60. Now we're down to 277 hours. 277 hours. Okay. This actually works out pretty well. I just stopped moving it. 278 hours-ish. Okay? What should we go to next?
24 hours in a day.
24 hours in a day. We've got 1 day. That's 24 hours. Okay, once again, get the cancellation there. Let's see what that ends up being, divided by 24. And now we're at 11 days. So I was off by a factor of quite a bit. I said 7 months, got 11 days.
When you said 7 months, I was like, crap, did I get it?
No. I was going by memory. You should always question that, Nick. About 11 and a half days.
All right.
So my apologies. Again, I was going by memory, and the last time I thought about this was when my son was born. Because I remember missing his 1,000th second and his 1,000,000th second. I don't plan on missing his 1,000,000th. But think about that. 1,000,000 seconds, because sometimes is 11 days. Right? 1,000,000 seconds is 11 days, but 1,000,000,000 is 31.7 years. Right? Think about that. Just think about the kind of insanity of that difference. And keep that in mind when you're watching the news and they talk about amounts of money that are being spent on certain things. When they make a big deal about $1,000,000 going here or $1,000,000 going there, and you realize that they've spent $500 billion elsewhere, realize that that million is nothing. Is nothing when you compare 11 days to 31.7 years. That's the difference. It's 1,000 times more. It's 1,000 times more. Does that make sense? Yeah, so keep that in mind. Keep that in mind. Keep that in mind when you hear, and that's the problem with the word million, and the word billion, and the word trillion, and the word quadrillion. I honestly think the word should take 1,000 times as long to say. And then maybe we'd actually have an idea. Like the word billion should be 1,000 times as long to say as million. It should have 1,000 letters, or something like that. Yeah, because then you would have to figure out some way to get it across without sounding ridiculous. It's very easy in news bites to just simply run through the word billion. 500 million here, oh, the national debt's $16 trillion. Big deal, $16 trillion. It's a huge deal, because a trillion is a million billion. Excuse me, a million million. I can call it by 1,000. Right, Kirsten's like, my head hurts. And it should hurt, because that's your taxpayer dollars going to those things. I mean, granted, we're all paying a smidgen into it at a time, but that's you paying for that. So just pay attention. That's the main reason that I put that problem on there, is to have you realize how much a million is. And if you haven't hit that yet, celebrate it. Celebrate it. You figure out when you were, and if you really want to be a dork, figure out the minute you were born. Right? Go back to your records. You call your parents and ask them, when was I born? And they'll tell you your birthday. No, I know that. What time of day was I born? I think it was in the morning. Yeah, but what time? Just keep pushing. And then get the time, and then figure out plus or minus 60 seconds from that, because I'm sure they were off by a little bit anyway. And then figure out when you're going to hit exactly 31.7 years. So 31.7 is an approximation. You can actually work it down to the billionth second. I celebrated at Smith Rock, plus or minus 60 seconds with my friend Zoe, the dog, because everybody else was running around at the time. So, get out, come here, snap. So anyway, that was my billionth second moment. Cool. There you go. Thank you, Nick, for bringing that up. And that's why I said we'll do it on Monday, because I'm going by memory that it was 7 months, and obviously it's not even close to 7 months. Yeah,
I
Doc.
probably have a Math 65 question here. How do you know, to begin with, which is my question, that you set it up with the numerator drawn in the right places? Because I did this one right, but when I got to the gallons per hour, I ended up with the division being divided the wrong way.
I have a suggestion that might help.
That's what I mean.
This might help. So you know what number you're starting with, right? You're starting with, in this case, 1,000,000, right? So, and you know it's going to be 1,000,000 seconds, so you've written down that unit.
Right.
This might help you out, and it's not even a Math 65 question, it predates that, and that's okay, it's a great one.
I just need to
Put that over 1. Put it over 1. Now there's not going to be any confusion as to where the other seconds has to go, is there? Because now you
because
clearly...
the seconds have to be below.
Yes, the next fraction has to have seconds in the denominator, because that one has it in the numerator. Whenever, and this goes back to something you learned many, many, many years ago. Whenever you see a number, 2, 3, x, c squared, 1, right? Anytime you see a number, you're allowed to put that over 1. As a matter of fact, it's correct to put it over 1. That's kind of the definition of what division by 1 is. It's a fundamental property of our number system, that division by 1 and addition by 0 don't change anything.
Right.
And what's amazing is that actually answers your question beautifully. It's such a fundamental principle. You probably learned it like when you were teeny tiny, but it's a fundamental principle. It's how we set up our number system. There are a few things called properties of our number system. Associative property, commutative property, distributive property, things like that.
It's just when it starts getting bigger, you know, like, like with the seconds or how fast your water was running
Yes.
and how quickly it filled up a quart
Yes.
jar. I evidently started it wrong because when I got to the end, I had the wrong numbers.
And that was a little bit more interesting because that's a rate, not just a number.
Yeah.
That's quarts per some number of
Right.
seconds. So that's when you have to say per means division.
Ha.
So when you say miles per hour, 60 miles
So
per
it should
hour
have
means
been
60 miles
one
per
quart
one.
divided by the seconds.
How many seconds, right? One
Okay.
quart divided by
I see.
2.4, 2.5, I forget how many
Totally
seconds.
upside down.
2.2 seconds, there you go. Yeah, there you go. And that's why I love this project. Have any of you guys ever done a project like this before? Or any kind of math like this before in a long time? Probably not. But yet, it's some of the most important math, and I'm not talking about the billion seconds, nor the fill in the Nalgene bottle with the garden hose. I'm not talking about that. Those are extraordinarily simplistic to my life. But this kind of dimensional idea is really important to know how to do. I designed the project originally for nursing students. Nursing students who have to do this kind of stuff before they get into the nursing program here, and they want like a pre project to do. So I created this for them, and it's been kind of it's slowly iterating ever since. And I realized that American math students don't see this very much, but it's super important to do. For many reasons, just being able to consciously go through and know, for something as simple as baking to something as complex as am I putting the right amount of antifreeze in my car. It all deals with that. And American measurements make it even worse, because we use the damn imperial system versus using the metric system. I mean, if we were metric, we'd be like, hey, just take the decimal and move it 3 places. And then it's meters to kilometers. No, we have to divide by 5,280, some stupid number that doesn't make any sense. We have to keep it in our heads. So, anyway, soapbox off. Cool? Makes sense? Does stuff make sense? Good. We'll see more rates today. Speaking of rates, because we're going to figure out how fast I was going on the bike. I'd like to apologize, offer apology. COCC, I apologize. I got totally reamed for grabbing that shuttle on, some of you guys didn't see it because you were down the hill further. The ones that were up the hill, one of those laps I took on Wednesday when you guys were timing me, the shuttle went the other way. I'm like, I think I can catch it. So I ran and clumped to the shuttle, and he slowed down as I got to him. Then I was like, what if I could grab out? And I got this great email later on that day. And so I apologize to everybody. Don't do that. But the great email was, we received an incident report about you grabbing onto a fender and riding, blah, blah, blah. And I was like, hanging my head. And the next line was, let's leave the Back to the Future antics off campus, and a smiley face. I'm like, haha. Don't do it. They probably don't know you like Adam knows me. Anyway, let's stop this and start it up again. And let's get, actually,